and welcome to another episode of FooBar. In today's episode, we are covering the difference between SNS, SQS, EVENTBRIDGE and KINESIS. If you want to know more about serverless, cloud computing or software engineer practices in general, subscribe to my channel in the red button below. I post videos on Tuesdays and on Thursdays. So let's get started! So today I want to cover a question that you ask me a lot whenever I upload a video about EVENTBRIDGE or whenever I put a video on SNS or SQS or KINESIS. I get this question: what is the difference between this and that service? Why I should use this or why I should use that? And I understand they're messaging things, services, so it's kind of confusing. So today, instead of doing a tutorial where I walk through different pieces of code in my computer, I want to sit down and address what are each of these services, what are the main difference between each of them, and also what are the main use cases for each of the services. And maybe after watching this video, you know which one to pick for your next project. So let's start with SQS. Simple Queue Service. SQS is the oldest of all AWS services. It was launched in 2006, so it's as old as the cloud. It's a queue service. Basically, you put messages in and you get messages out. Point A to point B, one to one. So it's great for decoupling services. You put a message and you get it in the other side. One of the key aspects in SQS is this pool service. So the messages stay in the queue until the service that is connected to, or whatever is on the other side, pulls the messages out. So there is a small message retention that you can define. I don't know, you can set it up until 14 days. If we talk about serverless, SQS is the #1 event source for Lambda functions. Why? Because it decouples Lambda functions, so you can connect as many Lambda functions as you want and put a queue in the middle, and you will have a very decoupled system that is fault tolerant. There are two types of queues when we talk about SQS. We have the standard queues, that if you create a queue, that's the one that will come out of the box, or then we have the FIFO queues, the ones that are first in, first out. That means that there is an order in the message. If we choose the standard queue, we'll have a very high throughput. If we go with a FIFO, we will get order in our messages, and that's sometimes important when we are using a queue. The other way, when we have the standard queue, order is not a promise, so we might have some messages in different order, but if we go through a FIFO, we get the messages in the right order, but then our throughput will get affected with that. Now let's talk about SNS, Simple Notification Service. The Simple Notification Service is different than queues. First is one-to-many. One puts a message and many will receive it. It's a pub-sub service, meaning that those that are receiving needs to subscribe to the topics, as we call it in SNS, that the one that is publishing into. So when we create an SNS, we need to create a topic to a different service to subscribe to. Another thing that you need to have in mind when we talk about SNS is these push mechanisms. Messages will come and will go directly to services. So we can overload the services with messages, and also the messages cannot stay in the queue, well, in the topic. They just go and get published. One thing we can do with SNS is to add filters. So we can subscribe to a topic and then we can add some filterings that will allow those messages to come into the service. So that will reduce the amount of messages that one initial service will start receiving, so we don't overwhelm. SNS is really good when we want high throughput. If your services can take it, that's a great option. In some cases, some people combine SNS with SQS. So then we can have a kind of pub-sub with a way not to overload the services. So we have the SNS, and then in each of the different topics before calling this SNS. We have a queue that will buffer these messages and will keep them, so then the services will not get affected. But it really depends on what you need to do. The other service I want to talk about is AWS EVENTBRIDGE. And this is a new service. It has around 1 year old. It's been launched in July 2019, so it's quite new. And I will say that it's one of the best launches, in my opinion, since Lambda. This service is a many-to-many messaging service, so you can send messages from many different providers to many different consumers. So it's great. This service might not have the highest throughput as SNS or SQS, but it has a really good throughput for decoupling services and creating a microservice architecture where no service is coupled to other service. How EVENTBRIDGE works is you have this event bus, and in the event bus we will define rules. So all the kind of coupling between the services is made in the rules. So we have service A that sends messages to the event bus, and in the event bus we will have different rules that every time a message comes in will evaluate against that message. So if we have 10 rules and one applies, then we'll see what are the targets of each of the individual rules, and that will send the message to the target receiver. We can have multiple targets and multiple rules that can apply to one particular message. So it's a very flexible system. Event Boost will guarantee the delivery on the next 24 hours of the event. So if the event cannot reach the receiver, it will retry and retry. So in that way, it makes it a little bit better than SNS that will just overload the receivers if there is not enough capability to get the message through. Also, one thing I love from EVENTBRIDGE is not only the capability of creating your own custom events, but also you can use AWS events and also third-party provider events. There is a list that is growing all the time of all the services that provide support for EVENTBRIDGE events, and it's super easy to configure, and it adds a lot of power into your application. And KINESIS is the last service I want to talk about, and this service is amazing for ingesting into your account, into your AWS cloud, millions of events. It has a capability of ingesting a super high throughput, and it can process the events in real time. So it's designed to take so many events, and it has tools that allow us to either run Lambda functions or store our events in different, data warehouses like Redshift, S3. It also allows us to run EC2s and things like that, and everything in real time, so we can process the events out as soon as they come in. KINESIS also will store the events for up to 7 days, so if you need to replay the events, or if something gets lost, you always have the event there ready to be replayed and try to populate your data source. So it's a great place for that. So now finally I want to talk about different use cases for all these services. Let's start with SQS. SQS is great at decoupling services. So we have services that we want to decouple, Lambda functions that we want to decouple. So basically Lambda A is not sending a message directly to Lambda B, or microservice A is not talking directly to microservice B. We can put a queue in the middle. This is great, it works very well, but when we get to the point that we have so many queues, maybe we want to think about Amazon EVENTBRIDGE. But this is one of the main use cases for queues. Particularly, I like to use queues internally in my microservices, in my logical microservices, when I'm building Lambda applications between two different Lambdas inside the same logical microservice. And then I like to use EVENTBRIDGE when I'm building the logical microservice to logical microservice communication. Because I think it's way easier to have a centralized place for all your events between microservices, and then to keep the communication between the Lambda functions internally to your bounded context Using queues is more control, is more like local, and I think it's less things to manage and to create, because it's so easy to create a queue and put a message through it. Another thing you can do with queues is using it to batch jobs, so you can put messages in the queue and then have a task that is doing those events and taking care of the events one at a time, and then taking out another event and taking out another event. And in that way, if you have a service that is sending a lot of messages with a high throughput to another service that doesn't have that high throughput, you can kind of leverage that with the queues. And I think that's a very powerful pattern in today's architectures, where everybody has different tolerance for loads. If we want to put it in front, maybe a legacy system or a third-party service where it has a different kind of capability to take the request for us, so that's something we might want to use in front. So let's look at an example. We are building like voting app or something. Imagine it goes in television at 8 o'clock. And we have a prime time offering, so we are building this app, and we are in charge of the backend. We need to process all the votes. Most of the votes will come in a kind of in a 5-minute interval when they launch the voting. So what is your favorite celebrity, or what is your favorite food? I don't know, whatever. And then what we could do is create a backend application that can tolerate that load, that we can throw all the millions of messages that all our viewers are watching at the same time, and we can have that. Or then we can build something that is a little bit maybe not that big, and it's not that huge, because we don't know, maybe our viewership is not the best that day. We don't know, we cannot predict. Even if we are on the prime time, we think that we will have a lot of people watching. We don't want to build something that is massive and then never use it and pay for it. So maybe putting a queue in front, it's kind of a good way to compromise. We don't need to build that big backend, but then we can put the queue, and the processing will take a little longer, might not be real time, but for the audience it's not a big deal, because they are voting. They might have, I don't know, 1 hour to vote. Most of the votes will come in the first 5 to 10 minutes, so then we have 1 hour to process all the votes. And the queue there will help us to separate these two systems, the one that is sending the votes to the one that is processing the votes and calculating the results. Now let's talk about SNS. As I said, one of the most common ways to use SNS is with the fan out pattern. That means to have an SNS in front, and then different queues for all the different services that are subscribed to that topic. In that way, we are not overloading the services. This is very common way to send messages to different systems and to inform if we have an event-driven application where different applications or services can connect to others to listen what are the events. This is kind of a great way to organize that. Also, this service can be used to send service alerts if we have something that we want to send to, I don't know, all our apps that are around, like, okay, will be a maintenance, we can use this. There is this push notification feature as well that we can use to leverage into multiple applications. And also using SNS, we can send emails and we can send text messages, so different users can subscribe their phone numbers or their email addresses into SNS, and whenever we have a notification to send, they will all receive it. So this is a system that has a lot of features. But one of the most common ways to use SNS maybe inside of an application is to allow parallelization of tasks, because we will have an event-driven application. So for example, we want to upload an image to our system, and then we need to do 3 tasks, and those 3 tasks are not related. So in the first task, we want to create a thumbnail. So that thumbnail, maybe we're uploading some kind of profile picture. So for the thumbnail, we just need to process it and store it in another S3 bucket. Then we need to, I don't know, add like a border or a frame or a watermark to our original photo, so it becomes part of our collection. That doesn't have anything to do with the thumbnail, there are different things. And then finally, we want to send an email to the person that upload the thumbnail to thank them, to upload the image, to thank them for uploading the image, or to some administrator that an image has been sent. So we could have an SNS that is sending this event, a new image has been uploaded to S3. So S3 can send that notification and we can connect it to an SNS. And then we can have 3 different services, very different. The Lambda that is sending the Lambda that is processing the thumbnail, the Lambda that is adding the watermark, and then another one that is sending the email, and they can act in parallel and have different life cycles. So now let's talk about use cases of EventBridge. So as I said, EventBridge is perfect for decoupling microservices. You will sit it between your microservices and on your organization. You could have multiple types of event buses. There is the one where all the AWS events will go through, but then you can create your own custom buses just for different parts of your organization, like, I don't know, marketing or product A or things like that. But I think unless you really need that isolation, I will try to keep it as simple to have one event bus where all the events are moving forward. So then you can really have an event-driven application. One of my favorite characteristics is the ability to get events from other AWS accounts. So you can hook multiple event buses together from different AWS accounts, so you can send messages through different AWS accounts and they can collaborate, so you don't need to build all your microservices in one AWS account. So you can have your product team working in their product, your orders team working in their account, and I don't know, their inventory team working in another account, because that's how normally companies have their accounts. They don't have one account where they do everything, they have multiple accounts for each of their teams. Another thing that I like is the capability of having different SaaS providers that can send events, because before we will need to use an URL and poke if there is a message for us, or then have a hook, a web hook that will send us a message, but that adds a lot of maintenance and things that we don't want to. So now many services can start sending message directly to EventBridge. And for example, the use case I want to mention is, I don't know, Zendesk. Imagine every time Zendesk is a ticketing system for customers. So whenever somebody has a ticket and they close it with a very bad feedback, then we can have an EventBridge listening to those type of events in Zendesk. And then whenever that happens, we can take that and then we can send it maybe to our microservice of customer satisfaction, and those persons there might maybe contact the customer directly and ask what happened, how we can help you, or they can give a free discount for their next purchase. So whenever we don't lose that customer, for example, to prevent churn. And that's something super easy to do with EventBridge and the capability that Zendesk has, for example. And finally, we have KINESIS. KINESIS is amazing to ingest a lot of data into AWS. One of the main features is the capability of real-time and the capability of doing analytics real-time. So the example I want to give is an example that is very common use in gaming and other mobile apps or web apps, when they are doing the clickstream events or IoT events, that they are capturing everything that the user is doing in their game. So for example, if you are playing a game, it's more probably that most of the events that you are doing in the game, you hoard something, you click somewhere, you pick some resource or something, is triggering an event that is going to the cloud, because in general game developers like to know how people are playing their games. So gaming companies tend to have petabytes of data every day sent to KINESIS, and that in general is stored for later analysis, but some of it is moved into dashboards where people, the game designers or the persons in charge of the game, they can see how their games are doing, like how many people are moving through levels, or how many accounts have been created, or things like that are coming through those events that are being sent directly from our mobile phone. Well, that's all I wanted to say, and I hope now you understand when to use one or the other. I think, in my opinion, KINESIS has a very specific use case that is more to ingest a lot of data from outside. EventBridge is perfect for decoupling microservices, and doing this type of kind of internal architecture of your services inside AWS. Queues are great either to manage load between different services that can take the load differently, or inside your own microservice to talk between different serverless components. And SNS is great when you want to send messages to other ones that are listening, like your push notifications, emails, text messages, or alerts into some particular systems. So that's my take. Those are my favorite use cases for each of the service, and I hope this video has been useful for you. Let me know in the comments box below what other questions you have that I can tackle in a video like this. And I see you in the next episode of FooBar. Ciao, ciao!